Hello, I am audible. Please confirm. You can write in chat box also. Okay, okay. Slide is visible. Week 3 fluid mechanics. Please confirm once slide is visible or not. Okay, okay, thank you. Let us wait 5 minutes. Hello, good evening all. So, I am audible. Please write in the chat box yes or no. Anyone, please write in the chat box. Okay, thank you. Okay, thank you. So, good evening, welcome all in week 3 fluid mechanics live TA session. I am Om Prakash Maurya, Department of Civil Engineering, IIT Guwahati. I am a research scholar. So, basically, today we will solve some problems based on your week 3 content of NPTEL, and the question belongs to your previous year assignment and other competitive exam. I have selected some questions from engineering services, so we will solve also. So your content, let me show the content. The week 3 content is about the Reynolds transport theorem and conservation of mass and conservation of momentum. So let us solve the questions. So let me share the question answer first. So hope question 1 is visible to all of you. The control system focus on a dash dash, on control volume focus on a, filling the blanks. So here option A and B is given. Set of fluid particle in first blank, and in the second blank region of space surrounded by control surface. Option B, region of space surrounded by control surface in the first blank, and in the second blank set of fluid particle. So please, based on your understanding of week 3 content, please try to give the answer of this question. You can write the answer in chat box whether option A or B correct. Here the question is about control system and control volume. This is the very basic things which is belong to your Reynolds transport theorem. So if you have any idea, please write in the chat box. So I think sir has explained very well what is the control volume and control system in the class or NPTEL online classes. Okay, Kedar is telling A and Shara is telling option A. Okay. Other student also, you write your answer in the chat box. Whether you may wrong or you may correct doesn't matter here, because this is not your exam. Based on your understanding, you please write your answer in the chat box. So I will wait 1 minute more. So other student also please try to write in the chat box. So whether option A and option B will be correct for the first question, you please write in the chat box. So after 1 minute, I will explain all the concept behind the control system and control volume, why we need the control volume, why we need the Reynolds transport theorem. So I will explain in this question. So you have 1 minute more if anyone want to give answer of this question. Okay, let me discuss the answer. So basically a control system and control volume is nothing but if you let me draw a pipe first of all. uh, Let me select the pen first. Okay, so if I draw here a pipe, why it is like that? And a student want to calculate velocity at this particular point, so there are two way of calculating, and water is flowing from this side to this side. So let's suppose this is point A. So velocity at point A, what is the value of velocity at point A? There are two way. First, you need to, this is the water particle is moving in the, you need to track a particular set of particle as it move at this place. You need to calculate velocity. So this is one way. Second way, you focus in a particular region. Let us suppose you select a region. When fluid particle is coming at the particular point, this fluid, when the fluid particle, let's suppose lots of fluid particle in and out from this particular region, lots of fluid particle is coming in and coming and out going. So you need to focus only this region, not move from here inlet to up to that point, and you can measure velocity in that section only. So this is the another way to calculate. So in first way, what we are doing, we are tracking a particular, or we are tracking a group of particle, and in the second we are focusing in a control region. So this is the second. The first one is the your control system, when you are tracking a particular particle or set of particle. When you are focusing a region, then this approach is known as your control volume approach. So option A will be correct for that. And your Reynolds transfer theorem, here is RTT, this is RTT. Your Reynolds transport theorem, what is do? Actually, whatever your fundamental equations are given, like your force is equal to mass into acceleration, so this is based on your control system. But in fluid mechanics, generally we use control volume approach. So how we will use this formula? This formula is converted from control system to control volume using RTT. So you can say control system is converted in control volume by RTT, Reynolds transport theorem. Always please remember this concept. And so this is all about your control system and control volume. Hope you people got it what I was trying to say you. Let us move ahead with the next question. So okay, the question 2 is control volume may be fixed, movable, deformable, or all of the above. So this is the second question. Please try to give your answer based on your previous lectures. For question number 2. Okay, Sagar is telling option D. Okay. Other student, please also you try to say. All students have 2 minutes. Within 2 minutes, please try to give the answer of this question. Okay, Kedar is telling option A. Okay. Or I want to say one thing more in the control system approach. In control system, fluid identity should not be changed. Fluid identity means here whatever you have considered the group or set of fluid particle, that particle should not change. In control volume system, one particle come out, another particle come out. So identity of particle is changing in a control volume, but in control system, whatever you have selected previously, the group of set of particle, that should not be changed in the control system approach. So this is the basic or fundamental concept behind your control system and control volume. So on that concept, you can expect your questions in the coming competitive examination because in that control volume and control system approaches there is not no question in the competitive exam till now. So you can expect questions from here also. Because nowadays the competitive exam is very challenging. In every exam, the lots of new questions coming. Not the previous year question is coming. So you need to focus on your concept or you try to read the textbook, then you can easily solve the new questions. Otherwise, very difficult to solve the new questions in the competitive exam or your exam also, your university exam and other exam. So only two student, other student want to give answer. Okay, let me discuss. So control volume may be your fix, like in the previous questions. Let me draw. You may select a region here. Maybe your region is shifted from here to here also. Maybe your control volume, it's depend on a particular which type of a study you want to do. If your study like that, you want to move your control volume, then it is possible. In your control volume, maybe your control volume after time t1, after time t2, your control volume may be shifted here. But in control volume, your new particle is coming and going out. New particle is coming and going out. Not like the control system. It may be deformable. Like shape is here like that, and maybe the shape will be different here. Maybe like that your shape will be. It is depend on. So all option will be correct for that. Your control system also, let me discuss in the control system. Your control system also may be deformable, may be movable. Movable, it is movable, but it may be deformable also. Not the particular if your group of particle is like that. After some time, it may be after traveling certain distance, so it may be like that also. So your control system also deformable. So now moving ahead on the next question, the extensive property and intensive property. Yes. Question number 3. Question 3. Extensive property and intensive property. Option A, independent of mass and proportional to amount of mass. Option B, proportional to amount of mass and independent of mass. So please, this is the basic, very basic questions, but it is important. You can expect the questions on extensive and extensive properties also. So please read question very carefully and try to give your answer based on your previous understanding in the NPTEL online course. Extensive and intensive. So sometimes in extensive and intensive, people are confused whether it is independent of mass or proportional to mass. So, okay, student are telling, Shideh is telling option B. Okay, Sagar is telling option B. Other student, please also try to give your answer. Okay. Other student, please write your answer in the chat box. Okay. Other student, please also write your answer. Okay, let me explain. So your extensive property is nothing but it's depend on your mass. Oh, your extensive property is nothing but, as a name suggests, extensive and intensive. Extensive means nothing but it is proportional to, it is depend on mass, extensive, and intensive is it is independent of mass. Like your density, rho, it is independent of mass. Weight, it is depend on mass because weight is equal to m into z. Density is equal to m by v. So in formula, mass is there, but it is independent of mass because without mass you cannot expect weight, but density, whatever, if you taking water, let's suppose that much water, let's suppose 100 liter, or you are taking 1 liter, your density will be same, rho 100 H2O and rho 1 liter H2O, density will be same. So remember, and you can explanation also you can read very well, written very well, what is written actually. So okay, so an extensive properties is a property that depend on size or amount of system. Example of extensive properties include mass, volume and total energy. An intensive property, on the other hand, is proportional to the independent of size or amount of system. Intensive property remains the same regardless of quantity of substance presented. Example of whatever I have given the example of H2O. Example of intensive property include temperature, pressure, density and specific heat. So hope people you are understand. So now the next question is Reynolds transport theorem establish the relationship physical equation between system approach to control volume approach. So question number 4. So please try to give your answer in the chat box. For question number 4. Hope everyone got it the previous question answer. Okay. Sagar is telling option A. Okay. Just few minutes back I have given some explanation about this question. So I need the answer from everyone. Please write your answer in the chat box. Everyone please write the answer. Because just few minutes back I have explained about the Reynolds transport theorem and the control system, control volume. So really I need the answer from everyone. Only okay. Kedar is also telling option A. Other student please also write your answer. Okay. Shidesh is telling option A. Okay. Okay, everyone telling the option A, it means option A will be correct because few minutes back I have explained about it. So we'll move ahead on the next question. Question number 5. So if you want to read the your detailed answer, what is actually written. The Reynolds transport theorem establishes the relationship between the derivative of an extensive property of a system, derivative of an extensive property of system. Remember please, extensive property which is depend on mass and derivative of the same property within the control volume. It provides a way to convert between Lagrangian, whatever we are taking the, let's suppose, what is Lagrangian and Eulerian approach. Let me discuss here few minutes. So I will take the same example, and one example I will also take as a your river flow. This is the bed, and water is moving this side, and this is the free surface, and here is water is entering. So similarly, what is Lagrangian approach? If you are considering a group of particle and you are tracking, it is moving here, it is after few minutes it is here, after few minutes it is here, and you are try to understand the behavior of this only set of particle. So this is the Lagrangian approach, or you can say the Lagrangian approach is based on the system approach. What is Eulerian approach? You need to select a particular region. It may be deformable, it may be movable, doesn't matter. So generally in fluid mechanics we consider the fix, especially for civil engineering. So in fixed control volume, so you will try to understand the flow characteristics within this region. Only within this region the fluid is coming in and going out, fluid is coming in and going out. So this is your Eulerian approach, or it is based on your control volume approach. So please remember, such type of question you may expect in the coming examination or coming NPTEL questions. So when we dealing with the analysis of fluid play and other transport phenomena, so this is written very well. Okay, so how you will measure in open channel flow? If you are having one instrument and your water is moving in this direction, so if you will throw your instrument in the river and your instrument is moving with the water, so this is your Lagrangian approach. If you will fix your instrument at a particular location, let's suppose here you have fixed already your instrument at the particular location, so such type of analysis is known as your Eulerian approach. So please remember. So hope everyone got it, or everyone understanding what I was trying to say. Now moving ahead in the next question. Next question is, a system must always entail the same shape, matter, position, thermal condition. So this is a little bit conceptual question, or if you will revise your mind, or if you will focus on my previous words, so you can very easily give your answer in the chat box. So few minutes back I was discuss about the system, control system. So if you will remember, you can very easily write your answer in the chat box. Otherwise, you just please try to understand. Please write your answer in the chat box. You have 2 minutes. Think based on your understanding of class, and you give your answer in the chat box. Okay, option B. Okay, Sara is telling option B. Other student, please also try to give your answer of question number 5. Whether option A, B, C, D, which one will be correct? Okay. Other student, please also write your answer. You have 1 minute. Okay. Rajnikant is telling option C. So let me discuss the answer of this question. So few minutes back I was discussing about the same thing like control system. So in control system what I was discussing, if you want to measure a velocity in a particular point or anywhere, so in system approach you will select a group of particle, and the identity of this group particle should not be changed. The same group of particle is moving here, the same group of particle is moving at this particular point, not another group, not another any particle is going inside of this set of particle. So what is actually, the system must always entail the same matter. Remember please, not position changing. Shape may be also changed. I was discussing previously also, the control system may change the shape. Thermal condition definitely it can change. So option B will be correct for that. Remember always. So let me moving ahead on the next question. Next question is about, okay. So again, it is extensive properties or intensive property. Question is based on that only. If momentum is taken as an extensive property of fluid, momentum, remember, the corresponding intensive property will be, if you are taking momentum as an extensive property of fluid, what is the corresponding intensive property? So if you know the formula of momentum and what is extensive and what is intensive, just previously I was discussed about the extensive and intensive property. So you can link that concept or that thing with your momentum formula. You can easily give your answer. Which option will be correct? Whether mass, energy, velocity, and power, A, B, C, D. So please write your answer. You please read the answer very carefully. Then you please try to give your answer in the chat box. Okay, Rajnikant is telling option A. Sara is also telling option A. Okay. Other student, please also try to give your answer. So actually question is asking about the intensive property. Intensive property which is independent of mass. So Sara and Rajnikant is telling mass. So it is not possible, because why? Intensive property is independent of mass and you are giving the answer of mass. So the first option is not possible. So please you think on three options. Which option will be correct? Sagar is telling option C. Okay, we'll see which option will be correct. So please you have another 2 minutes for this question. So please try to think on the question and write your correct answer in the chat box. Okay. Sara is telling option C. Okay. Other student, please. Okay, Sara is telling option C and Sagar is telling option C. Okay, within 1 minute, please. Okay, Kedar is telling also C. Okay, now I want to discuss the answer of this question. So if anyone want to give answer, you can write in the chat box. I'll wait 30 seconds only. If anyone, please. Then I will discuss. Okay, let me discuss. So actually, what is extensive and intensive? First, let me discuss. So your intensive means what? Let us suppose a property beta or property B, it is intensive, extensive. Let us suppose. It is extensive property. Intensive property, what will be the intensive? It is independent of mass. Intensive property means what? Independent of mass. Means if any property having mass, you need to divide that property with mass, then you can will find the that property as an intensive. If you have any extensive property like B, so when you will divide this B with mass, then you can get your B. Let's suppose you will get the beta. This will be free from mass. So similarly, your extensive property is given. Your extensive property is given what? Momentum, mass into velocity. So corresponding intensive property what will be? Your mass into velocity divided by what? When you will divide this thing with mass, you will get velocity. So corresponding your intensive property of momentum is what? Velocity. So option C will be correct. Okay, everyone is correct. So now moving ahead on the next question. So here explanation. So the next question is the momentum conservation principle, question number 7. The momentum conservation principle is based on the physical principle of zeroth law of thermodynamics, Newton's first law of motion, first law of hydrodynamics, and the Newton's second law of motion. So please everyone try to give the answer of this question. So which option will be correct? Momentum conservation principle. So you have three principle: mass conservation, momentum conservation, and energy conservation. So please always remember it is based on what principle? And what is the actually physical meaning of these all three conservation laws? So everyone please have everyone having 2-3 minutes. After 2-3 minutes I will discuss the answer. So in between please write your answer in the chat box. Okay, Kedar is telling option D. Other student please. Okay, Venkat is telling option D. Rajnikant also telling D. Asprit is telling D. Okay. Most of the student is telling D. Other student please also write your answer. Okay. Sara is also telling D. Yes, option D will be correct for that. Everyone correct. So now moving ahead on the next question. The continuity equation, this is the very basic questions. The continuity equation is based on the conservation of, you have only 1 minute or 2 minutes you can expect from my side. So you please give your answer very quickly. Which option will be correct? Okay. Kedar is telling option C. The answer of this question I want from everyone, please. Everyone please write the answer. The continuity equation is based on the conservation of energy, momentum, mass or force. Okay, everyone telling C. Kedar, Sara, Jasprit. Other student, please. Okay, Venkat is also telling option C. Sagar also telling option C. Okay. So everyone telling option C. Yes, definitely. Your continuity equation is based on the conservation of mass. So conservation of mass means what? Whatever the mass is in, mass flow rate. Mass flow rate in, mass flow rate out. The formula of this, rho A V, rho A V. So this is in and this is out. If density is same, that is your flowing fluid is incompressible. So what will happen? Your rho in is equal to rho out. So if you will if I want to give the here subscript 1 and this side subscript 2, so A1 V1 is equal to A2. This is velocity, remember please, not volume. A2 V2. So the conservation of mass means what? Whatever in, that mass will out. So this is the rate of flow of mass. So remember please this formula, you may expect question based on that. So now moving ahead on the next question, question number 9. The continuity equation is valid for only compressible flow, incompressible flow, both compressible and incompressible flow, and neither flow. So you please try to give the answer of this question, and just previously I have discussed. So if anyone, okay, Kedar is, oh no, okay, Kedar is telling option C, B, okay. So if anyone listen my words very carefully, then you can very easily give the answer, very easily. Okay, okay, Kedar is telling B, Sara is telling C, Kedar and Sagar is telling B, Venkat is telling B, okay. So if you people previously listen my words very carefully, then you can easily give the answer without any mistake. Okay, by the way, I will explain again whether it will be valid for compressible or incompressible. Okay, I am waiting for another student also. Write your answer. Okay, Venkata is telling option B. Okay. Okay, now I want to explain. So what I was discussed previously, mass flow rate in, or I can give the subscript 1, and mass flow rate out, I will give the subscript 2. So here you can write rho 1 A1 V1 is equal to rho 2 A2 V2. So this formula is valid for what? When your rho1 is different for in and rho2 is different for out. It means what? If density is changing from in to out, it means incompressible. It means compressible. And if your fluid is incompressible, so rho1 is equal to rho2. So this equation you can also use for what? Incompressible also, because rho1 and rho2 will be cancel out. This is for incompressible. So this is valid for both compressible and incompressible. Remember always, please. So option C will be correct for the question number 9. Hope you people got it, what I am trying to say. So now moving ahead on the next question, question number 10. Okay, this is a numerical type question, so please, for this question you have 5 minutes. Question 10. A water jet strike a stationary horizontal plate vertically of 18 kg per second with a velocity of 20 meter per second. The mass of the plate is 12 kg. Assume the water streams move in the horizontal direction after the strike. The force in Newton needed to prevent the plate from the moving vertically. So which option will be correct? A, B, C, D. Please, I need answer from your side. So please everyone give your answer in the chat box. Which option will be correct? Rajnikant, you want asking something? Is there any question from your side, please? So please everyone write the answer in the chat box. Okay, so now I want to explain the answer of this question. So the question is asking nothing. So your water jet, let's suppose a stationary horizontal plate. Let us suppose your plate is stationary here. Let us suppose, or let me draw here. Your plate is like that. And the weight, what is given, the mass of this plate is 12 kg. Mass of the plate is 12 kg. A, a water jet, a water jet like that is a strike to the plate, and water is horizontally moving in this side and in this side also. Both side horizontally is going with the rate of, what is rate, mass flow rate is given, or you can say the rho AV is given 18 kg per second, right? Assume the water stream move horizontally. Okay, I have drawn here. For the force needed to prevent the plate from the moving vertically. So this is the your force. So what is your force that will prevent your the plate moving vertically due to the your water jet force? So how you will calculate? So upward force, your jet force, right? And downward force is what? Downward force your mass, this force, and your plate weight also. So you can write the equation like that. Your force jet is equal to mass of plate, or weight of plate you can write here, mass into G, and your force. So this is the your equation. So hope everyone got it, how I have formed this equation for the particular questions. So now you can easily put the your F jet. How you will calculate the F jet here? And your M plate and Z already know. This is 12 into 9.81, and you need to calculate here F. So this is, now I want to show you the formula. So you can see here what is 20 is given in the, okay, your velocity is given here, one data is given, your velocity 20 meter per second. So what is the force of jet? Jet force is what? Your mass into velocity. Mass into velocity means here what is? This is a mass flow rate. Actual formula of force is what? Mass into acceleration. But you can write this formula, mass flow rate, that is, let me show you here, velocity by time. So mass by time, it is equal to m dot, that is mass flow rate, into velocity. So this formula is here. Mass flow rate is given how much? 18 into velocity is given 20. So it is 360 Newton. So here you can easily calculate, that is here your 12 into 9.81 plus F is equal to 360 Newton. So your F is equal to 360, 360 minus 12 into 9.81. So when you will calculate like that, 12 into 9, you will get this answer, 242.28 Newton. So you will get option C. So option C will be correct for that. So now moving ahead with the next question. Okay, I will show you the question number 5. Then after I want to take a break of 5 minutes. Okay. Oh, okay. Maybe option will not visible. Okay, don't worry. So the question number 11 is this. So please read the question, or if you want to take 5 minute break, you can also take. So after 5 minutes, we'll move ahead with question number 11. So now please I want to read the questions. Question number 11. Consider the below figure. The diameter of the inlet pipe 1 and outlet pipe 2 of the tank is given 5 centimeter. It is given already, and 7 centimeter respectively. The water flow of 0.01 meter cube per second through another pipe 3 is entering the tank. So it means here 2 inlet you can expect. You can say like that also, there is 2 inlet. One is your Q3 and another is your Q1. The velocity of water at the inlet is 2.5 meter per second. Here V1 is given 2.5 meter per second. If the flow is assumed to be steady and incompressible, it means what? This formula is valid. Incompressible means the velocity of flow at outlet. So here you need to, if V1 is inlet velocity, then we can write the V2 is your outlet velocity. So it means what? 2 incoming and only 1 outgoing. So as per the conservation of mass or conservation of mass, so Q3 plus Q1 is equal to Q2. So Q3 is already given. So what is Q1? So Q1 is nothing but your area into area at A1 and velocity V1. So pi by 4 into 5 centimeter is given, so you can convert in meter. Pi by 4 into d square into V1. V1 is 2.5. So it will come around. Okay, let me calculate. So you people also can calculate with your calculator. So pi by 4 into, or you can also try to solve 2.5. So it will come around 0.0049 it is coming. So I want to write 5. So meter cube per second. So your Q2 is equal to 0.01 plus 0.005. So it will be 0.015 meter cube per second. So now A2 V2, that is your 0.015. So what is 8? How you will calculate V2? 0.015 divided by A2. Pi by 4 into your 7 centimeters, 0.07. Oh, sorry. 0.07 whole square. So it will become around, so divided by 0.015 divided by pi by 4 into 0.07 square So it is coming around 3.8 meter per second, 89. So this is option B will be correct for that. So you can calculate like that also. So hope everyone got it, what I was trying to say. Okay, if please got it, please you can write in the chat box yes. Otherwise I will explain again. If anyone want to explanation, you can write in the chat box also. Need explanation, or you can write, if you got it, you can write yes in the chat box. Okay. Okay. Now moving ahead with the next question. A flat plate is moving away. A flat plate is moving. Plate is moving in this case also away from a nozzle at a constant speed 5 meter per second. A horizontal jet of water having a cross sectional area 10 mm square strike the plate with a velocity of 10 meter per second, then the force developed on the plate due to the jet is, or you can consider the density of water 1000 kg per meter cube. So please, option A, B, C, D is given. You please try to first take the attempt, then I will discuss with you what is the correct answer. So everyone please think on that. If your plate was stationary, then you can simply write the formula m dot into velocity, or you can calculate very easily. But here your plate is also moving. So in that case, how you will calculate? So just for hint, I can give you. Here you can apply the relative velocity concept. If you will apply here relative velocity concept, then you can very easily calculate the answer. So you can expect such type of question in the gate examination and other engineering services and the whatever the calculative type examination. So please you try to give your answer in the chat box. If you will use here your relative velocity concept, then you can very easily find out. Actually, in fluid mechanics, we always try to solve your force component with the help of mass flow rate into velocity. In solid mechanics, you try to solve the questions with mass into acceleration, but in fluid mechanics, most of the cases, we solve the question with mass flow rate into velocity concept. So remember these things. Now please, you can take attempt for this question. You have 5 minutes. I will give you 5 minutes. So please try to write your answer. This is very easy question, but little bit conceptual, because it will be, this question will utilize the relative velocity concept, because here what, your jet is moving, along with your plate is also moving. If your plate is fixed like that and your jet will, your water jet is moving like that, so you can very easily calculate your velocity of, or force, what is the impact of jet on the your plate. But here it is, plate is moving like that and jet is moving like that, so your impact will be reduced than the fixed one. So you can think also like that. So last 2 minutes, please, within 2 minutes, if anyone give answer, otherwise I will explain the answer of this question. Okay, now I want to discuss. So here is concept is nothing but what is force? Force is equal to mass into acceleration. This is simply. But you can write like that also, mass flow rate into velocity. So here is plate is moving and your jet is moving also. So mass flow rate into your relative velocity. So what is mass flow rate? Mass flow rate is nothing but, let me write here, rho AV. So rho AV means what? This is also your relative mass flow rate. So here rho A V relative square. So now you put the formula 1000 into area of jet. What will be the area of jet? That is your 10 mm here given, the pi by 4 into d square. And then you can calculate with the velocity. You will put here velocity, that is 10 minus 5. So 5 square, you will get the easily answer. So now I will show you the calculation part. So here density is 1000, area pi by 4 into, how it is written here. Okay, let me show you how you will calculate. So force is equal to rho A and V relative square. So 1000 into pi by 4 into d square, 10 mm is given. So 10 to the power 10 into to the power minus 3, like that. So this is area and V relative 10 minus 5, so 5 square. So it will become around 0.25 Newton. So like that you can easily calculate. Option A will be correct for that. So here the explanation is given. Here the explanation is given very well. I will upload this question in the in YouTube, no, not YouTube, in the Google Doc, so you can get from here. So you can read one by one. So of question number 13, in a normal adult, the average speed of blood through a aorta, the radius of aorta is 8 mm, is 0.33 meter per second. The average speed is given of the blood in the aorta is 0.33 meter per second. From the aorta of blood goes into major arteries. Remember, from the aorta your blood is going on the major arteries, which are each of radius 4 mm. If the speed of blood flow through the arteries is 0.044 meter per second, calculate the number of arteries. So this is very basic questions. Just it is the your based on your analytical mind. Just based on your you can give the very easily answer of this question based on your reasoning, how you are thinking about this problem, and what is your approach, what should be your approach. So please try to give your answer within 5 minutes this question. Cross section is given. Oh, in previous question cross section is given. Okay, let me see the question. Okay, cross-sectional area is direct given. That's why here writing the 10 into okay. Now got it, not in diameter. So you will not write this. So you will write what? You cannot write also 1000 into area is given already 10 mm square. So you can write 10 and mm square means 10 to the power minus 6 like that, and your 5 square, then you will get 0.25. Okay, so thank you for your addressing. Okay, now please let me show the question. Okay, so this question. Now please try to solve this question. Okay, Sara is telling option A. Other student, please also you take attempt. Very basic question. This is based on your mass of, just for hint, mass of conservation. Okay, other student, please also write your answer. Okay, Sagar is telling option A. Two students are telling option A. Okay, let me show you, or let me solve. Okay, Sara is telling B. Okay, let me show you how you will calculate. So here you will apply just for what is Q in and what is Q out. So Q out, I think in arteries. So area into your velocity of arteries, and here aorta radius is given 8 and your velocity is given 0.33 pi r square. So in mm I can write here, no problem, because both side is mm. So 8 square, here n you need to calculate. Area is given pi r square, so 4 square. Velocity, so your velocity is given meter per second. In here velocity is given also in meter per second, so 0.044. so n is equal to nothing but pi cancel, so 0.0 or 0.33 into 8 square divided by 4 square into 0.044. so this will be 4 times, and here you can write 100. If you will remove this point, you can write 1000 this side, so 2020 gone out, so here 10 only, and 11 threes are 33, 11 fours are, so 4 cancel out, so it is coming 30. So you can solve like that of this question. So hope everyone got it. Now moving ahead with the next question. So option B will be correct, 30. Okay. A circular jet of water emanating from a nozzle strike a stationary vertical plate normally. The force exerted is measured as 635 Newton. If the discharge from the nozzle is measured as 42.4 liter per second, estimate the diameter of nozzle at the exit in centimeter. Remember please. So please try to give answer. You have 5 minutes for this also. So please try to solve. So please try to give your answer. Okay, let me, or you have 1 minute more if anyone want to write. Same formula you can apply here. Your force is equal to mass flow rate, that is m dot into velocity. So m dot formula is equal to rho a v, and your velocity is given already, and velocity or a is discharge, so discharge is given. So let me, so you answer. So the answer of this question is how you will calculate. Your force is equal to what? Force of jet you can write here. A stationary vertical plate. So what stationary means, you will use here not relative velocity concept like previous. So your m dot, oh, what is m dot into your velocity rho a v into velocity. So here water means 1000 and discharge is given, means this value is given AV. So 42.4 liter per second you can write in meter by multiplying by -3. So this is meter cube per second. Only remaining velocity, and here 635 is given. You can calculate velocity from here. Now your discharge is equal to area into velocity. So area is what? Discharge divided by velocity. Pi by 4 into d square. So you need to calculate d square from here. So hope you got it what I am trying to say. So your d square is equal to what? Pi into discharge divided by area, not area, divided by velocity. So d is equal to root under, or 4 here also, or I am doing mistake anywhere. Okay, 4q, pi will this, not here. So 4q divided by velocity into pi. So you can calculate very easily like that. So let me show you. So here you can see how you will calculate. So now moving ahead with the next question, or in this here what is actually happening. So rho a v into velocity. So you can write rho, this will q, and this will write as a q by a. So your area is equal to what? Rho q square by f. No need to move with this because this is little bit long process. So this is very easy process. But here need to also your pi by 4 and d square is written, so you will do all these things. So you will get the answer 6 centimeter. Option C will be correct for that. Now the question number 15. Question 15 is given: a garden hose attached to a nozzle is used to fill a water bucket with a volume of 3785 liter. The inner diameter of hose is 2.5 centimeter and it reduces to 1.5 centimeter at the nozzle. If it take 25 seconds to fill the bucket to half of its total volume, determine the mass flow rate of water through the hose. So you need to calculate mass flow rate through the hose. So based on the above question, you please try to solve this. You need to write the answer of this question. So now let me show you the answer. So how you will oh sorry. So how you will see. So here just I have sent one YouTube link. So here actually I have solved already this question. Whatever I have the remaining question, so you can follow this channel also. So actually I have the question from previous year engineering services examination, question 37 based on the silo superlative years, and the next question is about your the advantage of triangular notch or over rectangular notch, and lots of question I have, you can see from here. So for that question today we have not much time. So for that question you can follow that YouTube channel also. This is my channel. And now moving ahead with this question number 15. For all this question you can follow that channel. Okay, so here the question is nothing. A garden hose attached to a nozzle used to fill water bucket with a volume. The volume of your bucket is given how much? The volume of bucket is given, total volume 37.85 liter. The inner diameter of hose is 25 centimeter, 2.5 centimeter, and it reduced to 1.5 centimeter at nozzle, like that. So here 1.5 centimeter. If it take 25 second to fill bucket half, 25 second, how much volume fill? Volume fill half, that is 37.85 divided by 2, volume filled within 25 seconds. 25 seconds. So determine the mass flow rate of the water through. Mass flow rate means nothing but rho A into V. So rho AV means nothing, rho into area into your length and time, like that. So you can write this rho volume into time. That is your volume. Or area, how you will calculate area? Pi by 4 into 0.015 square. So this is the area. And volume, how you will calculate? Volume is given already 37 point this much. So based on that, how you will calculate your discharge? Okay, it is very, or simply discharge formula is what you know already. It is very easy. Discharge is nothing but your volume divided by time, because it meter cube per second. That is volume by time. So volume is how much? Half volume, 3785 divided by 2, time is 25 second. So with that you can calculate 757 liter per second. With this formula also you can get. So hope you people got it, what I'm trying to say. For rest of the question you can follow that channel, because here I am unable to complete all the questions. So thank you for today. We'll meet again in the next class on next Monday. So if anyone have any question, please you can ask me. If anyone having any questions. Or on that YouTube channel, that is my personal YouTube channel, I have explained a little bit question of RRB JE also, BPSC also. Some I have teach the fluid mechanics from very basics. So you can follow my YouTube channel also, the that YouTube channel, if you are interested. So thank you all for your. Okay, okay, thank you.